爆啦，我睇到停咗幾廿秒啫嘛。頭先嗰啲係廢話嚟，啱啱好 cut 咗。Right, so 咁你幫我及住咯喎。Right, joints. So let's look at joints. There are a lot of joints in construction or connections, no matter. Sometimes we call it joints, sometimes we call it connections, and you should understand they are the same thing. So, so in a building, for example, what type of connections are we talking about? We can have beam column connections. Beams are connected to column, yes. Beams are also connected to wall or slab. So there are also beam slab connection. So there are also beam wall connection. For flat slab, right? For flat slab where you don't have any beams, you also have column slab connection. And slab could be connected to wall directly. And this list you can just go on. So there are actually many connections if you try to write in terms of elements. If you want to write in terms of material, yes, you can have a steel beam supported with concrete column. So concrete column. You can have a timber beam supported with steel column. And you can repeat this list, and this list go on and on. So there are many connections, types of connection in construction. But in structure, we don't try to classify all these connections, otherwise it will be just too complicated. So we just classify all connections into simply two types. Type 1 and type 2. That's it. Type 1 is called rigid joint to rigid connection. Type 2 is called pin joint. Sometimes people would also call it hinge joint or hinge connection. Right, those two connections, those two types of connection are not easy to define in verbally. So what we're trying to do is to discuss using my little model here. So let's just, what is connection? Connection is something that tries to connect two elements, right? Otherwise, you don't need the joint, right? The joint is trying to connect at least two elements together. Well, you can connect more than two. You can connect 3, 4, or 5, but the idea is just the same. Now let's say you have two elements here. You can call them beam or column, whatever. Two one-dimensional elements. Can it be two-dimensional? Yes, of course. The concept is exactly the same. Now let's first look at what is pin or hinge. So this connection is a hinge connection. Why is it a hinge connection? Because if I try to move one of them, it doesn't affect the other one. Right? That thing stays there. Or if you like, I can move the other one. So this connections is actually like that. 隨意轉動嘅。Right, that's what we define as a pin connections. And if you really need to write it down, I'll just say it's free to rotate relative to each other. Okay, free to rotate relative to each other. That's a pin connections between two members. There are many pin connections examples. Another one is something you have seen many times. That's a pin connection or hinge. So there are also, this thing here is also a pin or hinge connection. Element 1, element 2, door frame. Okay, it's free to rotate relative to this. Other examples? All these up here. Right, so that's the pin or hinge. If you know what that is, then what is rigid? Rigid is exactly the opposite of pin. So first I just write it down. What is the definition for rigid? It's not free. So I just add one word in front of this, not, and then I copy and paste this thing here. Not free to rotate relative to each other. So what does that mean? Using this model again, right? So this one is free to rotate. Whenever I try to rotate one of them, it doesn't affect the other one. But if I have something like this, this is rigid. Whenever I try to rotate one of them, the other one rotate at the same time. So they have to rotate together. You cannot rotate just one of them relative to the other one. So they have to rotate at the same time. Or in other words, some people would define it like this. This angle is 90 degrees. And it always remains as 90 degrees, of course, because they have to rotate together. So this angle is always kept at 90 degrees. But for this one, of course, this angle keeps changing. This one, it's rigid. That angle won't change. So it's not free to rotate. So, suppose these are door hinge. That should be something you write down. Door hinge is probably a good example of a hinge or pin connection. Right, so if you understand what that is, then you can go back to look at why we said the skeleton that we discussed last week is not a structure. So why this thing cannot stand up on its own? Because all these connections are pin connections. If instead of having a pin connections, you use rigid connection here, then this thing can actually stand up. But of course, human is not designed as a structure. We're supposed to move around. It's not a structure. We don't need to be in equilibrium like that. So that's why we have hinge connection everywhere for us to move around instead of like a building standing there for 50 years. Okay. So we got pin joints everywhere. In skeleton. Skeleton. Right, so that explains why that thing cannot stand up, because we are using or we are having pin connection everywhere. So if we are having pin connection everywhere in your building, same thing, it won't stand up. So that means some of the connections have to be rigid. Some could be pin. Right? Okay, so that's what I try to say about joints. Another thing before we go to equilibrium is this little figure here that I did not skip, I just missed that thing last week. Right, so these two are tall and slender. 高高幼幼呢啲叫做 tall and slender structures. These two figures is trying to demonstrate again something we mentioned last time, the importance of geometry in structure. Oh, these two structures, I don't mean this guy, of course. I mean that tree and that tower. Whenever you have long and slender structures like that, the first thing that comes to your mind is the dominant or critical, dominant load. Or you can also say the critical. 最重要嘅 load is the horizontal load or wind load. Horizontal load. So if you have a structure that the dominant load or the critical load is in the horizontal direction, it's better to have a bigger base like that or like that. It's always to have bigger base to make it more stable. Okay， 如果你有一個長條形嘅結構。Dominant load case 係 horizontal load， 個底部一定要係闊大一啲。Otherwise, it's not easy to make it stable。即係好似個人咁一樣嘅啫。你個人企喺度，如果你兩隻腳合埋嘅話，你個人喺旁邊有人擁你，你好容易反。但係如果你擘開隻腳企嘅話，咁就唔會有人咁容易捧得翻你，係咪？你搭地鐵嗰陣時唔會咁樣企㗎係嘛？會唔會啊？冇人咁樣企，架車喐你就反。咁你又唔使擘到太大隻腳企嘅，即係咁好得人驚。Right, so that's something I missed last week. Right, so I guess it's about time to start talking about equilibrium. So equilibrium, there are a few slides here which I also repeatedly on the second set of handout. Some of the slides I actually repeat on. Where is it? Right, these few slides. Are they the same? Yes. I sort of just repeat on the second set of handout. Right, so before we look at equilibrium, we're going to look at two important concepts, force and moments. For those who did physics before should know what they are. And before we look at force and moment, there are also something called the resultant and component that we need to talk about. Resultant and component. To talk about. And before we look at resultant and component, it's better to get a break. 而家可以 break a break 先嘅。